Welcome back. We are on friction on an inclined plane, and in front of us we have a question that reads, a body of mass 8 kilograms resting on a rough plane inclined at 30 degrees to the horizontal is about to slide down the plane. What is the frictional force required to prevent motion if, question 1, no external force is applied? Question 2, a force of 24 newtons is applied parallel and up the plane. Take gravity equals to 10 meters per second squared. Solution. The first question we have to ask ourselves is, what is the state of motion of this object? It is stated that it is about to slide down the plane. So which means the motion is down the plane. The word about to slide down itself tells us the nature of the motion, okay? That the object is about to slide down. So this is a limiting equilibrium. The word about to slide down, whenever you see it in a question, it talks about limiting equilibrium. To answer the two questions, the first one is we want to find the frictional force if there is no applied force. The second one is we want to find the frictional force if the applied force is 24 newtons. So let's try to draw a diagram for this. We are answering question 1 now. This is the inclined plane. We have an inclined plane here, and we have an object. The mass of the object is 8 kilograms. It is on a rough plane that is inclined at 30 degrees to the horizontal. So the question is asking us the frictional force that is required to prevent motion down the plane. So, like I said, the way we analyze the problem is the motion up or down. So since it says it's about to slide down the plane, we're going to accept that the motion is downwards. And we know that friction will act in the opposite direction to the direction of motion of the object. And the second thing we want to ask ourselves is it limiting equilibrium or acceleration? We know that it is limiting equilibrium since acceleration has not been mentioned in the question, and it has used the phrase about to slide down. So whenever you see that phrase, know that you are dealing with limiting equilibrium. And the third question is whether there is applied force. Well, for the first case, there is no applied force, and the second case, there is applied force. So we are dealing with the first case when there is no applied force. So if we have to complete the diagram, we have to indicate the force that is always acting downwards, okay? Which is mg sine theta, okay? So in the first case, we do not have any applied force, but we know that if this object is to slide down the plane, frictional force will act in the opposite direction. That is something that you have to know, okay? So let's try to indicate the direction of the frictional force. So we're going to have the frictional force acting up the plane. That is F. If we want to indicate the other forces, we have the normal reaction and the weight. Okay, so this is the normal reaction R, and the line that will come vertically downwards is the weight. Always make sure that you give a complete diagram. So this is the first case. Okay, when there is no applied force, the object is about to slide down, so which means the frictional force will be in the opposite direction. It's going to act upwards. To remind you, we are dealing with limiting equilibrium. So we know that for limiting equilibrium, the opposite forces that are acting parallel to the inclined plane, they must be equal. So that tells you that the frictional force must be equal to mg sine theta. Okay, so if we don't want the object to slide down, the force that needs to balance it must be equal to this force that always try to bring the object down the plane, which is mg sine theta. Okay, that is, they must be equal in magnitude, and that will be our answer. So mass is 8, gravity is 10, sine the theta is 30, so that is 80 sine 30, and 80 sine 30 is 40 newtons. So the frictional force has to be 40 newtons to prevent the motion down the plane. But for question 2, again, they gave us a force, okay? They gave us an applied force of 24 newtons. So let's try to have the diagram for that again. I will try to copy this diagram, then indicate the force of 24 newtons. Okay. This is the first diagram that we have. What we need to do is we have to indicate the applied force of 24 newtons that is also acting up the plane. So this is the 24 newtons. So is the body still in limiting equilibrium? Yes, because acceleration has not been mentioned in the question. But in that case, what will be our equation? And if you remember Newton's third law of motion, for every action there is an equal opposite reaction. So it means the total forces that are acting up the plane must be equal to the force that is acting down the plane. In that case, what can we say? We can say that the P, which is the applied force, plus the frictional force is equal to mg sine theta. Okay, the applied force P is 24 newtons. So if we want to find the frictional force, we're going to say F is equal to mg sine theta minus P. So the frictional force will be M is 8 times G is 10 sine 30 minus the applied force given in the question is 24 newtons. So that is going to be 80 sine 30 minus 24. 80 sine 30 is 40. That will be minus 24. So the frictional force will be 40 minus 24, and that is going to be 16 newtons. Okay, thank you very much for watching this video. In our next video, we will continue solving more examples regarding friction on an inclined plane. Do not forget to subscribe to our channel, like and share our videos. You can also comment in the comment section. Hit on the notification bell so that whenever a new video is uploaded, you can be updated.